Space, the final frontier. It beckons us with its mystery and grandeur, drawing us into its endless expanse. We long to understand its secrets, to unravel the mysteries that lie beyond our reach. One way we do this is by building models, creating tangible representations of the cosmos. Miniature versions of the vast cosmic dance, capturing the essence of celestial movements. But capturing the solar system's true scale is a daunting task, a challenge that tests our imagination and precision. The distances between planets are immense, stretching our understanding of space and time. It takes light, the fastest thing in the universe, over 8 minutes to travel from the Sun to Earth, a journey that seems instantaneous yet is vast. Then consider the sizes of the planets. Jupiter could swallow over 1,300 Earths, a scale that boggles the mind. This project is about more than just building a model. It's about understanding the mind-boggling scale of our cosmic neighborhood and the intricate details that make it up. It's about appreciating the delicate balance that holds our solar system together, the gravitational dance that keeps everything in place. It's a challenge we must embrace, a journey of discovery that brings us closer to the stars. Imagine shrinking our sun, a blazing ball of fire over 100 times wider than Earth, to the size of a basketball. This immense star, which powers our solar system, would be reduced to something you could hold in your hands. Now try to picture Earth, a tiny speck in comparison, just a few millimeters across, placed several meters away. This tiny dot represents our home, a small blue planet in the vastness of space. That's the challenge of representing the solar system's scale accurately. The distances between planets are so vast that it's hard to comprehend. Mars, a red marble, would be even farther away. This red planet, often a target for exploration, would be just another small dot in our model. The gas giants, Jupiter and Saturn, would dwarf our tiny Earth, appearing as massive spheres in comparison. While the ice giants, Uranus and Neptune, would be distant sentinels in the cold, dark reaches of our model. These planets, often overlooked, play crucial roles in our solar system. Accurately representing these vast distances and size differences is crucial. It helps us visualize the true scale of our cosmic neighborhood. It allows us to grasp the true nature of our solar system. By seeing these models, we can better understand the immense space that surrounds us, to understand our place within it. We are just a small part of a much larger cosmic tapestry. Creating the most accurate mini-solar system model ever requires incredible precision. We must consult with leading astronomers and planetary scientists. These experts provide the latest data on planetary sizes, distances, and orbital dynamics. Their knowledge guides our every decision, ensuring that our model reflects the most up-to-date scientific understanding. We'll use advanced software to calculate precise proportions and relationships between celestial bodies. This meticulous approach guarantees a model that is not only visually stunning, but also scientifically sound. Section 4. Crafting the cosmos from clay to computer models. Building our model involves a fusion of traditional craftsmanship and cutting-edge technology. We'll utilize three-dimensional printing to create highly detailed representations of each planet. The intricate details of Jupiter's Great Red Spot, the rings of Saturn, and the swirling clouds of Venus will be faithfully recreated. But technology is only part of the story. Skilled artisans will hand-paint each planet. They'll use their expertise to capture the subtle hues and textures observed by spacecraft. Section 5. Precision, the cornerstone of knowledge. Accuracy is paramount in educational models. Our mini-solar system will serve as a powerful learning tool, inspiring the next generation of astronomers, engineers, and astronauts. Every detail, from the size of the planets to the distances between them, must be meticulously researched and accurately represented. This attention to detail ensures that students develop a true understanding of the solar system's scale and complexity. It fosters a deeper appreciation for the beauty and wonder of the universe we inhabit. Section 6. Inspiring tomorrow's explorers. Imagine the impact this model will have on young minds. Students gazing upon the vastness of space, their imaginations ignited with curiosity and wonder. Perhaps they'll be inspired to pursue careers in STEM fields, driven by the desire to unravel the universe's mysteries and explore the unknown. Maybe they'll become the astronomers, engineers, and astronauts of tomorrow, pushing the boundaries of human knowledge. This model is more than just a collection of planets and stars. It's a gateway to endless possibilities. It's a beacon of knowledge, a testament to human ingenuity, and a source of inspiration for generations to come, lighting the path for future explorers. By building the most accurate mini-solar system model ever, we're not just recreating the cosmos, we're shaping the future one star at a time.